Hi everyone, this is Dr. Chinmay Bhatt. In this session number 27, we will see what are natural pigments. First, we will see what is a pigment. A pigment is that chemical compound which absorbs color and imparts particular color to that particular substance. Okay. Then this color appearance is because of so many factors, chromophore, exochrome, and the reflectance of light, absorbance of light, when visible light falls on a particular substance, and the reflected component what we see, and that's what color is because of. Remember one thing, pigments are different than dyes, so don't misunderstand. So dyes what you have, and they are different than the pigments, and you can see there are some difference. And pigment dyes are available in large number, both synthetic and natural, and they are less in number, and lower as compared to pigment. It's very high, and there are many differences. Temporary alteration in the structure of the dyes when it is applied on a particular substance, maybe when it is applied to cloths, but the pigments have the capacity to retain particular structure. And you must be knowing the dyes are usually organic. It may be indigo, all those dyes you must be knowing. So they are all organic. But mostly pigments have particular metal. Sometimes maybe toxic metal, sometimes intoxic metal, which has at the center. And then it is chemically bonded with organic compound. So that's what mostly pigments are. And dyes based printing inks do not last as long as the pigment inks. This is very important. So, but this pigment based prints made with the pigments last longer. And what are natural pigments? Natural pigment is a pigment that is found in nature and imparts color to that particular part. So these are some of the examples which are richly found in some plants. Chlorophylls, because of that chlorophyll, the leaf is green in color, and myoglobin and hemoglobin, which is red in color. Anthocyanins, which produces lots of color. It should be TH here. Anthocyanins, carotenoids, orange color it imparts, and flavonoids, and similarly tannins, betalains. There are many which are found in various fruits, vegetables, flowers. Because of these pigments, one by one, if you see anthocyanins, chlorophylls, because of this, that particular, whether it is fruit or flower, is colored. So you can see pigments in plants. These are some of the examples like chlorophyll, carotenoids, xanthophylls, anthocyanins, betalains. Okay, some of these are very common for you since earlier classes. And we will see in this session what are anthocyanins. Okay, anthocyanins are again they are derived. Basically they have flavonol structure. It can be even chalcone derivative flavonols. Chemically, anthocyanins, catechins like this. Chemically these anthocyanins can be one of these, but mainly they are flavonols. You must be knowing flavonoid structure. It is having 3 rings. 2 are aromatic and 1 is with a heterocyclic ring. And you can see these are different flavonoids: isoflavone, flavon, flavonone, flavone, and chalcones. Again, different flavonoids. And you can see the basic structure of anthocyanin, which is similar to flavonoid. It's also having 3 ring and oxygen heterocycle. So if you see the color of the cherry, it's because of anthocyanin pigment, which is present in cherry fruit. Orange, red, blue colors, and food like strawberries and cherries. That's what it's a strawberry fruit. Color of cherries also. Because of anthocyanins, and some grapes, vegetables, and all because of anthocyanins. So you can see it here, different types of grapes, strawberry, and cherry fruit, and apple. All this color mainly because of anthocyanin pigment in that present in that enriched amount. So these are certain properties of anthocyanins. They are water soluble and they are amphoteric in nature. That means they exist both in acidic and basic form. They can exist under different conditions. They change color with change in pH. Okay, it's very important because they change color. with a change in pH. Anthocyanins have been characterized by two absorption bands, 460 and 275. You can see it in one falls in the visible region, which is responsible for its color. Red radish color, again, it's one of the most stable anthocyanin color. So radish red one is because of anthocyanin. Okay, that's all in this session. These are some of the references which you can go through, which I also referred, and please go through some of the YouTube videos and or some classes in website like NPTEL, which provides online classes. Thank you for watching.